All right, so we have done systems of equations with two variables, right? X and Y. We solved them three different methods. The first method was graphing. The second method was substitution, and then we had elimination, okay? And the word problems that y'all have done, that even on the quiz and those linear programming, those were two variable, right? They sold, blueberry muffins and, chocolate chip cookie muffins or whatever. So, two different variables that you're trying to solve. What do I need to solve for to figure out my most profit? Those are two variables, right? You can have systems with three variables. And so when you have the two variables, your goal was to get rid of one so that you could solve for one and then plug it in and figure out the other. That's really the goal with three systems, okay? You have to have, if you have two variables, you really need two equations. If you have three variables, you really need three equations because your goal is to get rid of all the variables except for one. And the method that we're going to only use for this is elimination. Okay, so we're going to eliminate down. All right, so they give you these solution types here. They can all intersect at one point. They can be parallel like this, or even two of them can be parallel, or they can intersect at a line or at a plane. Typically for these, you're going to see, I'm not going to give you a lot of special cases here. Typically, you're going to see one point that meets all three of them. But here's the thing. Your points are no longer X, Y. We're adding a third one. So your answers will be X, Y, Z. You will have three answers if you have a system with three variables because you're looking for the answer to all three. So let's look at this first one. All right. So my goal here is to eliminate one variable out of all three equations. And so when I look at something like this, I'm going to say, what is my easiest variable to eliminate? Now remember, in order to eliminate, you have to have a positive and a negative of the same number. And so when I look down these, first of all, you want to make sure they're all in order, X, Y, and Z. Look down them, and you can see clearly that this Y would be the easiest one to eliminate, right? I have a positive and a negative, a positive and a negative, okay? And so what I'm going to do is I'm going to take two of these equations. So let's say I take the first two, and I am going to do elimination. It's already set up to eliminate, right? My y's will eliminate here if I just add. And so I'm going to do that. I'm going to say add this guy. These will cancel. 1 and 3x give me 4x. Negative 2 and positive 1 give me negative 1. And then negative 9 and 13 give me 4. All right, so I've taken the first two and eliminated a y. Now I'm going to take any other two. So I don't want to take these same two. That doesn't help me. I want to take two different ones. In this case, I would probably go ahead and do the last two because that's also set up nicely to eliminate. Everybody see that? And so this guy is set up nicely to eliminate. I have a positive and a negative y for these two as well. And I'm going to do exactly the same thing. I am going to add down. And I am going to get 3 and 2 x's give me 5 x's. My y's cancel. 1 and my 4 give me 5z. And 13 and 17 give me 30. Now, just a quick note, and this is true for all elimination. If you look at this guy right here, what do you notice? 5, 5, and 30. They all have a common factor of what? 5. So I can actually reduce everything by 5. I can actually take this guy and divide everything by 5 to make my number smaller. So this becomes x plus z equals 6. All right? Everybody see that? Now, I now have two variable equations. So now I'm just going to do the elimination like I've always done. I am going to take this equation and I am going to just add down between these two that I created. You can see that it's also set up nicely. What's going to eliminate here if I add? My z. So I have 4 x's, 1 x gives me 5 x's, 4 and 6 give me 10. I can easily see that x equals what? 2. Now, here's the thing. Now I'm just going to backfill them, okay? So I'm going to take this 2 and I'm going to plug it in over here. All right? And I'm going to say 2 plus z equals 6. I now know what z equals. What does z equal? Just subtract 2. We're not dividing. Subtract 2, we get z equals 4, right? Now I'm going to take the x and the z, and I'm going to go back up here to one of these and plug it in. And I promise I just picked the easiest one that I think it is. So if I think the first one's easiest, then I would say x, that's a 2, plus y, I don't know, minus 2 times z, which I do know, equals negative 9. Right? So I have 2 plus y minus 8 equals negative 9. Combine your 2 and your negative 8, we get negative 6. Add your 6 over. What does y equal? Negative 3. Yep, positive and negative, okay? So now I have an x, a y, and a z. And that's how I'm going to list my answer. X, y, z. All right? And so it seems like when you first look at it that it's overwhelming, but really you're just doing 2, and getting 2 equations that just have 2 variables. Than just using elimination. And once you solve for one variable, you literally just walk backwards and solve for the other 2. So this is the same exact process as solving by elimination that we did in the first few sections. Notice that some of these equations are missing a variable. This one is missing a z, this one is missing an x, this one is missing a y. And so when you have something like this, you could do substitution if you wanted to. You could take 2 of these and solve by substitution. I could say that, x equals 6 minus y and plug that in. I typically just solve by elimination as well. I pick a variable that's already missing. So let's say I already have maybe x is missing from this. So I can use some other equation to get rid of an x or get rid of the y, and then I'm down to 2 variables. And so if you're already missing a variable, use the other 2 to eliminate the variable that you're missing. And you'll see that sometimes when you get to these. One of them's missing a variable, use the other 2 to get rid of that same variable. And you're still going to solve by elimination. So here's your systems. Reduce the systems to 2 variables, solve that, and then just substitute back. All right? Try this one, and then we're going to work on test review.